electrical code does not permit the use of a fluorescent light fixture as a raceway. This prohibition is in place for several crucial reasons relating to safety, accessibility, heat dissipation, and the intended design and listing of the equipment. Firstly, using a fluorescent fixture as a raceway can compromise the fixture's ability to dissipate heat effectively. Electrical conductors carrying current generate heat, and if these conductors are run through the confines of a light fixture, the heat buildup can become excessive. Fluorescent light fixtures are designed to handle the heat generated by their own internal components, such as ballasts and lamps. Adding the heat load from additional conductors can lead to overheating, which can damage the fixture's components, reduce its lifespan, and, more seriously, create a fire hazard. Secondly, accessibility is a major concern. Electrical codes emphasize the importance of being able to access conductors and connections for inspection, maintenance, and repairs. When conductors are run through a fluorescent fixture, accessing them becomes significantly more difficult. The fixture may need to be disassembled to reach the conductors, which is time-consuming and increases the risk of damage to the fixture or the conductors themselves. This lack of easy access hinders proper maintenance and troubleshooting, potentially leading to undetected problems and increased safety risks. Thirdly, the mechanical protection of conductors is another critical consideration. Raceways, such as conduits and cable trays, are designed to provide physical protection to conductors, shielding them from damage caused by impacts, abrasion, and other external factors. Fluorescent light fixtures are not designed or tested to provide this level of mechanical protection. The fixture's enclosure is typically made of relatively thin metal or plastic, which is not robust enough to withstand the same types of physical stresses that a dedicated raceway can handle. Using a fixture as a raceway exposes the conductors to a higher risk of damage, which can lead to short circuits, ground faults, and other electrical hazards. Fourthly, the electrical code mandates that electrical equipment be used only in accordance with its listing and labeling. Listing refers to the process by which a recognized testing laboratory, such as Underwriters Laboratories or Intertek, evaluates a product to ensure that it meets established safety standards. When a fluorescent light fixture is listed, it is tested and certified for a specific purpose, which is to provide illumination. The listing does not include the use of the fixture as a raceway for other conductors. Using the fixture in a way that is not covered by its listing violates the code and voids the manufacturer's warranty. Furthermore, it creates a potential liability issue if an electrical incident occurs. Fifthly, the potential for electromagnetic interference, EMI, is another reason to avoid using fluorescent fixtures as raceways. Conductors carrying alternating current generate electromagnetic fields. When these conductors are run in close proximity to sensitive electronic components, such as those found in lighting control systems or dimming circuits, the electromagnetic fields can interfere with the operation of these components. This interference can cause flickering, erratic behavior, or even complete failure of the electronic devices. Dedicated raceways are often designed to provide shielding against EMI, while fluorescent fixtures are not. Sixthly, consider the issue of conductor fill. Electrical codes specify the maximum number of conductors that can be installed in a raceway of a given size. This is to ensure that the conductors do not overheat due to overcrowding and that there is sufficient space for heat dissipation. Fluorescent light fixtures are not designed to accommodate the same number of conductors as a dedicated raceway. Using a fixture as a raceway can easily lead to exceeding the allowable conductor fill, which violates the code and creates a safety hazard. Seventhly, the integrity of the grounding system can be compromised. A proper grounding system is essential for electrical safety, as it provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. When conductors are run through a fluorescent fixture, the grounding connections may not be properly maintained or may be inadvertently disconnected. This can compromise the effectiveness of the grounding system and increase the risk of electric shock. Eighthly, there is the issue of voltage drop. When conductors carry current, there is a voltage drop along the length of the conductor. The amount of voltage drop depends on the conductor's size, length, and the amount of current it is carrying. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Running conductors through a fluorescent fixture can increase the length of the conductor run, which can exacerbate voltage drop problems. Ninthly, think about future modifications and expansions. Electrical systems often need to be modified or expanded to accommodate changing needs. If conductors are run through a fluorescent fixture, making changes to the wiring can be difficult and time-consuming. The fixture may need to be removed or disassembled to access the conductors, which can disrupt the lighting and create a safety hazard. Tenthly, the presence of sharp edges and protrusions inside the fixture can damage the conductor insulation. Electrical codes require that conductors be protected from abrasion and damage. The interior of a fluorescent fixture may have sharp edges or protrusions that can rub against the conductor insulation, causing it to wear away over time. This can lead to short circuits, ground faults, and other electrical hazards. In summary, while it might seem convenient to use a fluorescent light fixture as a raceway, it is a violation of electrical codes and a dangerous practice. The potential risks, including overheating, lack of accessibility, inadequate mechanical protection, and compromised grounding, far outweigh any perceived benefits. Always use approved raceways for running conductors and ensure that electrical equipment is used only in accordance with its listing and labeling. Following these guidelines will help ensure the safety and reliability of electrical installations. Always consult the latest edition of the National Electrical Code, or NEC, and local electrical codes for specific requirements and regulations in your area. Adherence to these codes is crucial for ensuring electrical safety and preventing potential hazards. In addition to the core reasons already discussed, several other factors contribute to the prohibition of using fluorescent light fixtures as raceways. The design of the fixture itself plays a significant role. Fluorescent fixtures are typically designed with specific internal wiring configurations to accommodate the ballast, lamp holders, and other components necessary for their operation. These wiring compartments are not intended to handle additional conductors that are not directly related to the fixture's function. Introducing extra conductors can disrupt the fixture's internal wiring, potentially leading to malfunctions or even electrical failures. The materials used in the construction of fluorescent fixtures are also a consideration. Many fixtures, especially older models, may contain components made of materials that are not compatible with the heat generated by additional conductors. For example, some fixtures may use plastic components that can melt or deform if exposed to excessive heat. This can create a fire hazard and compromise the structural integrity of the fixture. Furthermore, the installation of conductors within a fluorescent fixture can create a situation where the conductors are subjected to undue stress. The fixture's enclosure may not provide adequate support for the conductors, causing them to sag or become pinched. This can damage the conductor insulation and lead to short circuits or ground faults. The proper support and securing of conductors are essential aspects of electrical wiring practices, and using a fluorescent fixture as a raceway can make it difficult to meet these requirements. Consider the impact on the fixture's lighting performance. Adding conductors to the fixture can obstruct the light output, reducing the overall illumination provided by the fixture. This can be particularly problematic in areas where adequate lighting is essential for safety or productivity. Moreover, the presence of additional conductors can affect the fixture's ability to dissipate heat, leading to reduced lamp life and increased energy consumption. The potential for future problems is another reason to avoid using fluorescent fixtures as raceways. Over time, the fixture's components may degrade or fail, requiring maintenance or replacement. If the fixture is also being used as a raceway, the process of repairing or replacing the fixture becomes much more complicated. The conductors must be disconnected and rerouted, which can be time-consuming and increase the risk of damage to the wiring. Furthermore, the presence of additional conductors can make it difficult to properly inspect the fixture for signs of damage or deterioration. This can delay the detection of potential problems and increase the risk of electrical hazards. From a regulatory perspective, using a fluorescent fixture as a raceway can create compliance issues with electrical codes and standards. Electrical inspectors are responsible for ensuring that electrical installations meet the requirements of the applicable codes and standards. If an inspector finds that a fluorescent fixture is being used as a raceway, they will likely issue a violation notice requiring the homeowner or business owner to correct the problem. Failure to comply with the violation notice can result in fines or other penalties. In addition to the NEC, other standards and regulations may also apply to electrical installations. For example, the Occupational Safety and Health Administration, or OSHA, has regulations that address electrical safety in the workplace. These regulations may prohibit the use of fluorescent fixtures as raceways in certain situations. The liability implications of using a fluorescent fixture as a raceway are also significant. If an electrical incident occurs as a result of using a fixture in this way, the homeowner or business owner may be held liable for any damages or injuries that result. This liability can extend to the electrical contractor who performed the installation. It is important to note that insurance companies may also deny coverage for losses resulting from non-compliant electrical installations. To ensure electrical safety and code compliance, it is essential to use approved raceways for running conductors. There are many different types of raceways available, including rigid metal conduit, electrical metallic tubing, or IMT flexible metal conduit, and non-metallic conduit. The choice of raceway will depend on the specific application and the requirements of the electrical code. When installing raceways, it is important to follow the manufacturer's instructions and the requirements of the electrical code. This includes properly supporting and securing the raceway, using the correct fittings and connectors, and ensuring that the conductors are properly installed and terminated. It is also important to avoid overloading the raceway with too many conductors. The electrical code specifies the maximum number of conductors that can be installed in a raceway of a given size. Overloading a raceway can cause the conductors to overheat, which can lead to insulation damage and electrical hazards. In addition to using approved raceways, it is also important to ensure that all electrical equipment is properly grounded. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. This helps to prevent electric shock and other electrical hazards. The electrical code specifies the requirements for grounding electrical equipment. It is important to follow these requirements carefully to ensure that the grounding system is effective. When working with electricity, it is always important to exercise caution and follow safe work practices. This includes energizing circuits before working on them, using insulated tools, and wearing appropriate personal protective equipment. If you are not comfortable working with electricity, it is best to hire a qualified electrical contractor to perform the work. Electrical work can be dangerous, and it is important to have the necessary knowledge and skills to do the job safely. In conclusion, the electrical code prohibits the use of fluorescent light fixtures as raceways for a variety of reasons, including safety, accessibility, heat dissipation, and code compliance. Using approved raceways and following safe work practices are essential for ensuring the safety and reliability of electrical installations. Always consult the latest edition of the NEC and local electrical codes for specific requirements and regulations in your area.